Industrial Talk is brought to you by Palo Alto Networks. You've heard me talk about my friends at Palo Alto Networks, Zero Trust OT Security, delivering a comprehensive security solution for all OT assets, networks, and remote operations. But did you know that the Palo Alto Networks solution provides over 1,100 app IDs for OT protocols, over 500 profiles for critical OT assets, and over 650 OT-specific threat signatures? Now that's best-in-class security delivered. Learn more about Palo Alto Networks' Zero Trust OT security solutions and how you can achieve 351% ROI over 5 years. Learn more about the Palo Alto Networks solution by going out to paloaltonetworks.com. That's paloaltonetworks.com.
Welcome to the Industrial Talk Podcast with Scott McKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, thank you very much for joining Industrial Talk, and thank you for your continued support of a platform that is dedicated to industry professionals all around the world. You are bold, you are brave, you dare greatly, you innovate, you solve problems, you are making the world a better place. Thank you very much for what you are doing. We are on site right now. SMRP is the organization, and we are right on the floor with all of the vendors that are around here, and there's just great solutions. Absolutely wonderful event. Put that on your calendar. And by the way, if you are interested, if you are in the reliability space and you're saying to yourself, how do I get more involved? You need to go out to smrp.org. They have a lot of programs, a lot of opportunities to engage, a lot of opportunities to network together. So it is a must. That if you're just into the reliability, that is your first stop. smrp.org. Make it happen, Captain. All right. Howard is in the hot seat. Thank goodness Howard is. He's the first one out of the gate, and he's going to dazzle you because he is dazzling. Howard, how are you doing?
I'm doing great. How you doing?
I'm well, man. Got too many things going on, man.
And by the way, I agree. Yeah, I did my 11 years on the board.
Did you
for
really?
SMRP, yeah, all the way up through 2019.
No
and
way.
It was probably the best time I've had, other than my technical stuff. But
I love the collegial nature of it. Everybody's willing to help.
Oh, yeah.
I don't care what it is. Everybody's willing to help each other, trying to keep that asset up and running and whatever, you know.
Yeah, and influence the industry. I mean,
yes. It's come a long way. You've seen a lot of changes.
Oh, yeah.
Holy
I mean,
cow.
Government relations was a big deal under my tenure.
Yeah.
Going out and influencing the rules and regulations that affect our industry. That was great.
Yeah, I can't complain. So you're having a good conference then?
Yeah, so far. I mean, 2 hours last night, right, was fantastic. It made the
Delicious
whole week.
food.
Oh, yeah. Well, yeah. It wasn't all fried.
When in doubt, man, it's delicious food,
Yes,
most definitely.
yeah,
All right,
absolutely.
for the listeners out there, Howard, give us a little background on who you are.
I am the president of MotorDoc LLC, which is an electrical reliability company. We do services, we do consulting, and of course, we distribute the Empath electrical signature analysis equipment.
Let's level set here. You just said empath. So let's just so that I'm on board and I understand what's going on. What is empath?
Well, I can tell
signature.
you how your motor feels.
Okay, tell us a little bit about that.
Yeah, electric motor performance analysis tool hardware. It actually is the original device developed at Oak Ridge National Labs for testing electrical and mechanical components.
By the way, they have great augmented reality.
Oh, they do.
Yeah, and virtual reality training.
Yeah.
Go ahead.
Yep, they sure do. But at Oak Ridge National Labs, they had developed this technology back in the 1980s. And contrary to popular belief, current signature and electrical signature was meant to look at mechanical systems. And during the 1990s, people focused on it for things like rotor bar testing, which I kind of find that amusing because I used to use a clamp-on analog ammeter to do the same thing.
Right.
Vibration analyst first. But Right now, we use the technology. Ours is the only one capable of doing a full wind turbine. So we'll walk into the base of a tower without having to climb.
No way.
Do I look like I climb?
No. I was getting I really was. I was getting to the point of going, no, I get it. That's great that you can do a wind turbine, but I know that they're not on the ground.
And they don't have elevators. Walk in there in about a minute, be able to tell you the condition of the transformer, all components in the generator, the gearbox. That's 3 stages of gearbox, 1 or 2, and plus 1 or 2 planetary gear sets. The main bearings turning at under 14 RPM, and then even the condition of the blades.
In a minute.
In a minute, all at once. So the difference between vibration and ultrasound and electrical signature is we use the magnetic field, the air gap of the machine is the transducer. So you see how everything in the system interacts.
Okay, let's take that use case of the wind turbine. So you go to the wind turbine. Mm-hmm. It's tall.
Yep.
It's turning.
It's really tall.
It is. It's turning. It's doing its wind turbine thing.
Yep.
How do you hook that up? How do you get that in? What, do you just sort of stick it on the tower itself, or what is it?
Yeah, pretty much. Yes. When we first started, it was primarily like the old GE 1.5 towers. So we'd go in and we'd connect directly to the 690 volts and the current on the cables going up tower. It was dangerous. We had to shut the towers down. You had to stand outside the tower, start everything back up, all the arc flash requirements and so on and so on. It would take an hour or so a tower. And then we started going off of the CTs in the tower and going into
hold it, CTs, don't give me an acronym.
Oh, sorry, current transformers.
Thank you.
We were going into the low voltage side, low energy side of the cabinets. We've identified those in every type of wind turbine now. And so we can go in, they don't have to shut the towers down. We walk in the base of a tower.
Brilliant.
We connect, and they love it because we don't have to shut down a tower. You're talking about a small tower is 1.5 megawatts. The larger towers will be 3 to 5 megawatts now on shore. And then we also do a remote version of it. We've had remote analysis or continuous electrical signature analysis since 2017.
So when you do this, we're using as use case, when you create that analysis, and you come up with the health of that asset, pretty much.
Yeah.
Do you also go into and venture into the predictive type of area where you're saying, okay, it's got some issues here and maybe a little issues here, but whenever you have your planned outage, you got time.
Oh yes.
Or you better shut it down.
The number one failure in a generator right now is the winding connection in the rotor. Every single what's called a doubly fed induction generator. It's a wound rotor generator. Every one of them has the exact same type of failure mode. And we can detect those up to 14 months out. The only other way of detecting it is with boroscope testing, and you're testing that weeks out.
Just for my giggles, how often do they take the wind turbines out for maintenance? Planned maintenance, not.
How often are they supposed to, or how often?
Yeah. What's the industry standards? What's the rule of thumb on and to perform some sort of maintenance?
Okay, I happen to be chair of standards for wind, solar, and energy storage for American Clean Power. That's my latest thing.
Did I just feed you a line?
Yes, you did.
No, thank you.
So
you're welcome.
Yeah. So technically, there's certain things like greasing and everything else that are done quarterly. There's other basically what we always do. The neat thing about a power plant, a wind farm, which is your power plant itself, everybody keeps going, oh, that's the generator, and they look at a single tower. No, that's the cell of the generator. The generator is the whole site. So when you go in, well, we'll get into that in a second. But you can shut down individual towers to do maintenance. Okay, so they'll send a crew out, and they'll say, we're going to work on this tower, and this tower today, that kind of thing, because you can only climb so many towers, right? And you're only allowed to climb so many times per day.
Are you really?
Yeah. Yeah. I mean, you have to remember, you're talking a vertical ladder 300 feet plus. So
well, they didn't do that when I was a transmission lineman. We climbed tower after tower after tower the whole day, hot washing.
Yeah. Yeah. Well, I mean, they're lucky now. I mean, they do have climb assist, which is something you hook on. And if you ever go into a tower, you'll see a little motor at the bottom of the ladder, and then you go up to a deck, and then you get off there and you reconnect. You have to wear fall protection.
Yeah. Sure.
And, but it takes a while to go up because of all the rules that have to be followed. I mean, some of the kids I run into in the field, I mean, they just scramble up the tower. They're up there in a couple of minutes.
Oh, yeah.
The average time to hit the top of a tower is about 10 to 15 minutes. And then you have to take your equipment up. So they'll usually bring it up either, depending on the tower type, either through a crane on the inside, so you don't carry your tools up with you, or on the outside.
Boy, things have changed.
Just a little bit.
They abused me.
Yeah. Well, you figure I think it was in one of the safety standards meetings where we identified that the average technician starts seeing ankle and shoulder issues, after 10 years if they're not careful. So they've done climb assist. There's some companies out there now that have retrofits that attach to the ladders, so the ladder then becomes an elevator. So you can step on two pedestals and you have two handles so you don't grip anything, and it takes you all the way up.
So back to the original question. It makes sense that if I'm able to conduct the right testing and to be able to do it in such a way that I can, in some level of confidence, be able to, I hate to say it, but predict or determine the health of that asset. And then that means I can, with confidence, sweat the asset a little bit. I don't have to have that planned maintenance in a sense where I'm going, every 6 months I've got to do this, every 6 months I've got to do that. You're able to sort of sweat the asset a little bit because you're receiving the information that is necessary to make those determinations.
Right, and our technology has been determined to be over 90% accurate in wind. So
is everybody knocking down your door?
We've done 10% of all the towers that exist so far.
Yeah.
And all of the service companies use our technology or use us directly.
Because without a doubt, if I'm not having people climb up and down, they only climb when it's necessary.
Right.
And I would imagine there is a benefit that, okay, this portion of the wind turbine is beginning to show signs of failure or wear or whatever the terminology is. So bring that.
Well,
don't bring this. Bring that and send that up.
I'm gonna hit you with something even more, and that's part of what we're going to talk about at 11 o'clock. But one of the differences by doing a systems analysis is I can identify the drivers that cause the wear before the wear starts.
Yeah.
So if I see a misalignment, I will see the energy losses through components before it starts to age them rapidly. So we're talking about something where things are, my favorite self-made word, mitigable.
That is, man.
Yeah. Before you, so for instance, I might see one we did on a tower. We identified, 14 kilowatts of loss in the thrust bearing, 5 kilowatts of loss in the main bearing. And that helped us identify that a spacer was missing in a coupling right after it had been rebuilt.
And you can do this all in a minute?
Yes.
That, you can come down to that level of detail in the determination of that.
Yeah, and here's something even more fun.
Talk to me.
Is it's not load dependent.
No way.
So, so we convert everything over to decibels, and it's relative to the load. So when we detect a problem, the limit on electrical signature analysis in general, because you'll hear it, and it actually depends on the resolution of the technology being used. Some will have a resolution where the peaks that you're looking for will blend into harmonic peaks.
Yeah, sure.
So you'll lose the condition peak you're looking for. So they'll be limited to 50 or 60% of load. Our particular technology, which is built by Framatome, which is a small $12 billion nuclear services company.
Yeah. Very good.
The resolution is down to 0.005 hertz. So we can go all the way down to
in a minute. Yeah. I'm still struggling with that. You can do all of that in a minute?
Yep. Yep, 12,000 samples per
Well,
second,
okay,
48 seconds in length. And
So what's the pushback? I mean, how if I'm a wind farm owner, what is it? Come on, it makes sense.
There is none. There is no pushback.
Yeah, I don't understand.
And in the industry side, in 2018, after Dr. Eshelman introduced me at the Vibration Institute, I got up in front of the crowd and said, "Sorry, folks, vibration's dead." So now we actually have some companies and partners, such as Allied, that are going through and retrofitting vibration equipment with electrical signature analysis.
Oh, that wasn't well received.
I know, isn't that wonderful?
I was. I've been very fortunate. I've been to that event, and they're very passionate. They're very passionate about their vibration.
But since that time, about a third of the presentations have added either motion amplification or specifically on current signature and electrical signature. So the industry is adopting it. As a matter of fact, the people that can look at and actually analyze the data will tend to be vibration analysts.
Well, yeah, and it makes sense. Cat whatever 4 or whatever 3. Yeah.
Data collection, everybody thinks it requires an electrician or an electrically trained person. Well, that's for the data collection part if you're going to manually do data collection. But actually analyzing the data, we're looking at amplitude versus frequency, just like with vibration.
It would seem to me that if I had a wind farm and I had X amount of wind turbines, right, to have a clear health picture of those each individual assets would seem to be pretty important.
It is, absolutely. As a matter of fact, the other fun part about this is we get to see the conditions of the electrical system, right? So we see power quality as well. I was just at the National Renewable Energy Laboratories a few weeks back talking to them about the fact that we have been identifying a resonance that occurs in the grid that everybody knows about, but they were unaware is actually fatiguing the towers. So now we're starting down the research path of how to correct that at the grid level so that we can extend the life of wind turbines.
Fatiguing the tower.
Oh, yeah.
Yikes.
16, 21, and 51 hertz.
See, the hardest class I ever took was simple harmonics.
Yep.
There's no such thing as simple harmonics. It was a fallacy.
Yeah, as a matter of fact, in industry, we're doing a lot of work in ground and neutral harmonic distortion. We've been finding losses in plants ranging from about 10% of the total energy consumption out to one facility we did was 32%.
How in the heck do you stay focused? What are you focused on at MotorDoc LLC? There he is, right there with his shirt, branded shirt.
I have no life.
Because it just seems like you're. It seems to me that you're just at the tip of the iceberg. There's just so much more that can be gleaned from this.
My whole career, I've gone if other people don't want to go down a path and because it's difficult, I've done this since the Navy. Right, I ran motor repair shops on an aircraft carrier. We took on the stuff that nobody else wanted to take on, the important equipment that were normally being tossed over the side. We figured out how to do it. That was my team there. Then I went to a repair shop, ran a field service group. Our job was take on anything and everything everybody else had to walk away from. And then when I was at the University of Illinois, I ran the Energy Resources Center, and part of that was because starting in '93, I worked with the Department of Energy, all the challenge programs. So during all that time, I was looking at the areas of research that people were walking away from because they were too complicated, or they were considered not popular. Everybody wants to be popular, right? So I went after the stuff that I knew needed to be done that nobody else wanted to do. So here I am.
How do they get a hold of you?
You're saying you get straight to MotorDoc.com.
MotorDoc. Tell me about that name a little bit. MotorDoc. I got the motor. Yes, I got it.
Yeah.
Doc.
Well, back in the Navy, the captain of the Roosevelt, I was a plank owner. He goes, they were used to refer to us as rewind gods when you ran the motor repair shop. And I didn't like that. I was pretty religious at the time. And he looks at me and he goes, well, in that case, you're the MotorDoc, and the name stuck.
There it is.
Yep. So the PhD came
You were
after.
absolutely wonderful. I really enjoyed this guy. And again, we just scratched the surface. I really appreciate your time
I look
here at
forward to doing
SMRP.
this another time.
Yeah.
Absolutely.
Yes. Why wouldn't we? Absolutely. All right. You can tell we are on site. SMRP, the 31st?
Yes.
It's 31.
Yep.
Yeah. 31st annual SMRP conference here in Orlando. Yeah. Put that on your calendar for next year. Let me just see if I understand. There's a couple of events that you need to be aware of. You've got next year's, and that would be 32. That's the math.
Yes.
Because it's 31, that would be 32. Make sure that you put that on your calendar for next year. You're going to have all the contact information as well as all of the information for next year's SMRP conference out on Industrial Talk, as well as you're going to have all the contact information for Howard because you need to connect with him. That is your call to duty right there. All right. We're going to be right back with another great conversation. Stay tuned. We will be right back.
You're listening to the Industrial Talk Podcast Network.
Howard Penrose. That's his name. Your call to action is to connect with Howard. Find out more about what they're doing at MotorDoc. That it just must. That was SMRP. That was in Orlando. That was a great show. Look for 32. Go out to Industrial Talk. We're going to have all the contact or the links to 32. SMRP 32nd Annual Conference, must attend event. I say it all the time. If you go out to Industrial Talk, there's a button. The button says, hey, let's connect, let's talk, let's do whatever. There's an action, right? And because Industrial Talk is a platform for industrial professionals to amplify the voice, get that message out, you need to participate. You need to be a part of it. I make it as easy as possible. Click, fill out a form real quick, a simple form, nothing fancy, and you'll be talking to me and see what we can do together to collaborate to get that message out. Be bold, be brave, dare greatly. Hang out with Howard. Change the world. We're going to have another great conversation coming from SMRP shortly.